I'm going to show you one more rule involving sines and cosines and stuff like this with a general triangle. Right, so I'm just going to draw a triangle. Let's this time again, I'm just gonna label it as I did before. Right, so B A what am I gonna put here? C, it's just a general triangle. We've given some significance to the lengths and angles so I can talk about them in terms of algebra. So what's the area of this triangle? Well, what's going to be? If I had the height, which I don't, but if I did have the height, that was h. The area would be just a half, base times height. So a half ch. That would be the area. Area equals this. But I don't actually have h. So how do I get h? Well, let's look at this triangle over here. Right, this right angle triangle. H is b sine a. I just project b onto the vertical. So the area is a half bc sine a. But I could have also used the other triangle on the right. So I could have also said that h was equal to a sine b. So I could have said it is a half ac sine b. And what else could I have done? I could have somehow treated b as the base of the triangle and got the height this way, right? Instead, if you rotated the angle around and did a similar thing, you'd also uncover, and I'll leave this as an exercise for you to check, you could also get a half bc sine a. So those are, sorry, a half ab sine c. So those three are really saying the same thing. And that's an interesting way to represent the area of the triangle, for sure. But just learn how it is really applied, right? So it's a half AB sine C, so it's going to be a half AB sine of the angle between them. Let's have an example for context. So let's draw a triangle. Let's have 63 degrees, shall we? 5 and 8. So now you can calculate the area of this. It's just going to be a half 8 5 sine of 63. That'll work out to be, I don't know, 17.8, something like that. Check that, guys. And alright, I mean, all of my questions in these videos have been pretty basic so far. Let's step it up just a little bit. They are supposed to be examples to help you learn, though, so I won't go too overboard. But let's say this is the angle 40 degrees. It's an isosceles, and therefore that these sides are the same, right? If I knew that the isosceles triangle had an area of 100, right? If I knew that the entire thing was 100 centimeters squared, then what would x have to be? Well, I know the area is a half x squared sine 40. So that must be equal to 100. So I would just rearrange that. I would just get x squared is equal to 200 divided by sine 40. Yeah? And square rooting that, x would be equal to 17.6. That's what I have here. So those are two applications of this new kind of sine area rule thing. Yeah, so up until this point, we've done pretty much we've learned all the basics you really need to know in order to start doing things. Next, we're going to talk about solving trigonometric equations, which is not really that difficult. I've hinted how to do it in the previous videos. Just involves the arc sine, arc cos functions and how to do various things of that.